For our second part of this week, we're going to look at utility, marginal utility, and how consumers satisfy their wants. So utility in the context of economics isn't a utility like gas or electric service. It's more like a measure of satisfaction or how much pleasure you get from something. But using something like joy or enjoyment isn't exactly right because you get utility out of things that you need. For example, if you break your arm, you get a cast on it, you get utility from that, but you're not necessarily enjoying the cast. So it's basically a satisfaction of a need or a want. So if you look at this particular graph, one way to think about utility is to think about the value that a good or service would have to a particular consumer. And the value is that same concept as how much they're willing and able to pay for it, or the reservation price. So the utility they get is really their point along the demand curve. And then the price, right, is the price they have to pay for the good, and the difference is consumer surplus. So you can fit the concept of utility or value in with what we've been doing when we were talking about price and consumer surplus. Okay, so each time a consumer consumes a good or service, he or she gets utility from it. They get some kind of satisfaction. If they didn't, they would not consume the service. The total utility is the total amount of satisfaction that you get from consuming one or multiple units of a good. As you consume additional units, your total utility goes up. So if you eat one slice of pizza, you have a certain amount of satisfaction. If you go back for a second slice, you'd have additional satisfaction, and you would be more satisfied. And you would keep eating until you were full, and that would be your maximum total utility. Your marginal utility, there's that term marginal again, is the additional satisfaction you get from one more unit of a good. So it's not the total, but just that satisfaction from one more unit. So marginal utility typically goes down even when total utility is increasing. So for example, the first piece of pizza tastes amazing, the second piece not quite as good, the third piece maybe you're getting a little bit full, it doesn't taste that great anymore, and then additional pieces eventually you'd stop eating it because eating more would make you sick. So I do a simulation in my AP micro class where I have people eat marshmallows and rate their level of satisfaction with each marshmallow, and as they go along they find that each marshmallow is actually less satisfying. So this is a graphical representation of how consuming additional units of the same good, in this case it's polo shirts, total utility increases but marginal utility decreases. And you can see, if you look at this, that marginal utility is basically the derivative of total utility. By the way, you don't need to know that. So if you're not familiar with derivatives, don't worry about it. Consumers will continue to purchase additional units of a good as long as the marginal utility of doing so is greater than the price. If the prices of two goods are different, then we can predict what a consumer will do by looking at marginal utility per dollar spent. So at consumer equilibrium, marginal utility per dollar spent on, for example, good X would be equal to marginal utility per dollar spent on good Y. And those would both be equal to 1, assuming that the person has enough money. So let me show you how that looks on this chart. This makes it a lot easier to understand, I think. Assume that this guy, Frank, has an income, or what we officially call a budget constraint, of $130. So he has to decide how to spend his money, how much of it to spend on gas, and how much of it to spend on food. Gas is $10 per gallon, and food is $20 per grocery bag, or $20 per unit. So to complete this table, what we're going to do is for each unit, okay, the first gallon of gas gives him marginal utility of 60. And this is just his self-described rating. There is no ultimate scale of utility or marginal utility. Every individual is going to be different. So I might consider that out of 100, a scale of 100, I get a marginal utility of 25 out of the first gallon of gas. Somebody else might say 90, right? It just depends on how much you value gas. And we also don't have, as I said, an absolute scale. So you can see he's going up to 115 here on the first unit of food. I don't know what that's out of. It's just basically an arbitrary number we're picking so that we can compare the value assigned to two different goods. So he values the first unit of gas at 60 and the first unit of food at 115. But that doesn't mean that he will buy food first, because what we want to do is we want to consider the marginal utility per dollar spent. So we have to take the marginal utility and divide it by the price, and in the case of food it's $20 per unit. So marginal utility divided by the price for the first unit of food is $5.75, and for gas it's $6. So the first thing that he's going to do is he is going to buy, right, this first unit of gas. So what you should do is pause for a moment and fill in the table. And then you'll have the calculations that will show his value all the way down. I'm going to pause for a moment and fill in the table, and then I will return. Okay, now I have the table filled in, and hopefully you've taken the time to fill in the table for yourself so you can see the value per dollar spent on each unit. So if we look at this and we want to know where is he going to spend his money, the first thing he's going to do is he's going to buy this, right? He's going to buy this first unit of gas. Then we say, well, what's he going to spend money on next? He's going to spend money on this because 5.75 is the next highest rating. And then 5.5, and then 5.25. As we continue going, though, we have to be careful because, remember, Frank has a budget constraint of 130. So we need to keep track, right? How much did he spend? He spent $10 here, $20. These each cost 20, so 40, 60. He's already spent $60. So here we go, 70, okay, 90, 100, okay, 120, 130, money's all gone. Okay, so that is the combination that he's going to buy. And you'll notice that those two numbers are actually equal at that budget constraint. Okay, does the combination of G equals 1 and F equals 6 satisfy the income constraint? The answer is yes, because F equals 6 would be 6 times 20 would be 120, and 1 gallon of gas would be 130. Yes. Is that the utility maximizing combination of goods? No, because Frank would have a lot more utility from following the path we just stated. Every time that he buys the unit that gives him the most satisfaction per dollar spent, every time he makes that the next unit, he is moving toward maximizing his utility. Which direction would Frank like to reallocate his purchases? Well, you can look up here and see he wants more gas and less food than this statement says. Okay, and what is his utility maximizing combination of goods? It's what I just showed you. So that's how we determine the utility maximizing combination of goods.